The theorem states that this is our theorem one on the quadrilateral. So we have a parallelogram. So it says the opposite sides and angles of a parallelogram are what? Are equal. So what's going to happen to you when you're going to be busy working man? They're going to give you something like this. They say if ABC is a parallelogram. Now, once you say something is a parallelogram, we're trying to say this one is parallel to this one. Okay? We're also trying to say this one is going to be parallel to this one. But now there are certain things that are missing that we can add. And then when we add them, it's going to be our statement and what and reason. Let's go to our statement. What did our theorem say? Our theorem says opposite sides and angles of a parallelogram are equal. So is this a parallelogram? Is this a parallelogram? Yes, this is a parallelogram. If this is a parallelogram, and then what we then can conclude is this. It means the following. AD is going to be equal to what? To BC. They didn't give us that one. You see that one again? When they are going to give us this thing as a parallelogram, if they give us this thing as a parallelogram, now we're going to conclude by saying, okay, man, it means which AD is going to be equal to what? To BC. Not only that, AB is going to be equal to what? DC. And then angle A, you see angle A here, let me use a different color so that you see. Angle A, this angle here, is going to be equal to angle C, this angle here. And then angle B is going to be equal to what? Angle D. Where does that come from? It comes from the theorem here. It means which is the learner, if you are given something like this, when I have the right to tell them, Amara said, I know angle A is going to be equal to angle C. Now you need to give me a reason here because I didn't tell you that. I just told you what this thing is a parallelogram. What are you going to say as your reason? Number one, you're going to tell them these are opposite angles of a what? Of a palm. Yeah, you will use this one here. Look at this reasoning here. You're going to say opposite angles of a palm equal. So if you tell me what A is equal to C, you're going to say opposite angles of palm equal. Yeah, you can even use this equal. Now, where does that come from? It comes from the fact that you said this thing here, it's a parallelogram. What else is true that they didn't write on this diagram? What else is true that they didn't write on this diagram? You can say AD is going to be equal to what? To BC. And then if I ask you, why are you saying AD is going to be equal to BC? You say, I say that one is also simple. Look at this one here. You say we have opposite sides of a palm, what? Equal. So you have opposite sides of a palm, what? Equal. Now, let's start with theorem one. We're going to take an example of theorem one, and then we'll check it from there. Look at example number 7 here. If you look at example number 7, I want us to apply theorem number 1. We're going to apply theorem what? Theorem 1. Now, they say to us here, given a parallelogram, calculate the interior angles of this palm. So you are going to be given this thing here is a parallelogram. They say DEML is a parallelogram. That's what they need to tell us. So now we know theorem 1. What does theorem 1 say? It says number 1, if this one is 2x, what do you expect this one to be? This one should also what? 2x. If this one is x, I expect this one to be what? X. Where does that come from? From theorem number 1. Okay. So how can we approach such a question? They say DELM is a parallelogram. Calculate the value of x and hence the size of the interior angles. Now, guys, we shouldn't forget our prior knowledge. We shouldn't forget some of the things that we already know. Now, here's what I know. I know what this one and this one, they're equal. That's the only thing that I know. I know what this one and this one, they're also going to be actually equal. But equally so, I know this. Remember, actually, this is a parallel line. This is also a parallel line. Yes. What kind of a shape do they form this thing here? What kind of a shape do they form this one? U shape. What do you know about U shape? They have 208. So I'm going to start by saying that to them. I'm going to say, okay, and now it means 2x plus x. It's going to be equal to 180 degrees. Then they are going to ask me, why am I saying that? All interior angles. And then because we have DM, which is parallel to what? To EM. And then you're going to get your X, man. I'm going to just calculate X. How are we going to get our X? We're going to tell them, okay, it's simple. 3X is going to be 180 divided by 3 divided by 10. X is going to be equal to 60 degrees. That was the first question. Calculate the value of X, hence calculate the size of the interior angle. Now, if this one is 6, what is going to be 2 times 60? So it means we can come and tell them, we know this one. This one here is going to be equal to what? But we can then tell them about L. At L, they didn't tell us say anything about L. We're going to tell them L using our theorem 1. We're going to say L is going to be equal to 120. When they ask us why I'm saying L is going to be 108, what are we going to say then? These are opposite angles of better. And then after this one, it's 60. This one, because X, and come and put it with this one here, it's 60. We tell them, okay, E is 6. That one is you just calculated it. And then put D is equal to 2 multiplied by 60, which is going to be 120. We're left with one more M. What is going to be M? M is going to be M. M is going to be equal to what? 6. Now, why do we say M is 6? Because they didn't tell us that one. It's opposite angles of the palm are equal. Are we fine, guys? Yes. Now, let's go to number B. What are we doing for number B? For number B, they say, calculate the sizes then now. If DE, which is this one, DE, is equal to 2 times DM, which is this one. So we write that statement. DE is equal to 2 times DL. And then they say LM. You see LM, starting from here. You can highlight it. LM is equal to what? It's equal to 10 centimeters. Now, they say calculate the length of the other sides. How would you calculate the length of the other side? Based on what we know from theorem 1, what should we say if it's you? You are going to tell them, number 1, what are you going to say? I want to hear that. Opposite. We're going to start by telling them which we know what is DE. That's the first one. What is going to be DE? We're going to tell them DE is going to be equal to ML. They can give us that one. DE is equal to ML, which is going to be equal to what? To 10. Now we need to justify why are we saying this? Why are we saying this? Opposite sides of the palm. I'll say fine. You haven't updated, say, this one is 10 here. This one we know now as well, that's 10 centimeters. But remember, what did they say here? They said DE equal to is going to be equal to 2 times DM. And this, but now we know what is DE. What is DE? It's 10, which is going to be 2 DM. And this, divide by 2, divide by 2. What is going to be DM? 5. It's going to be equal to, we come and update. This one is 5. And this, that one, it's not a theorem. It's 5 because they told us which it's given. They said that one is 2 times that one. You can even tell them which here, if they want to know why I'm saying that this one was given. But there's something which was not given, and then we just apply the theorem. What is that? EL. Okay, we can try to get EL. What is going to be EL then? Yeah, EL. EL is going to be equal to DM. You see the way I'm doing it? I'm telling them EL is equal to DM, which is equal to 5. And then the reason why I'm saying this is because we have opposite sides of trans. I got difficult. Asame now number 1 now. Asame now number 1. Right, that's it.